Thank you very much, Cameron. Appreciate that. Don't see my slides coming up. There we go. Okay, so what I'm a little bit different in terms of the content of my presentation today. We'll talk a little bit about some of the connected vehicle and work zone activity we have going on up in Northern Virginia. We do have a kind of a SPaT component to our connected corridor, but that will not necessarily be the focus of this presentation. So if you have any questions about any of our SPaT related efforts, I can address those offline or through some other means. So when I mentioned the connected corridor, in partnership with VDOT, we have developed what's called the Virginia Connected Corridors, and really there are two components to that. There is the Smart Road, which is down kind of in our backyard down in Blacksburg. It's a test track facility. We have 8 RSUs down there and a full-up test track where we can evaluate the safety and the performance of applications before they're migrated to the Northern Virginia test bed. Up in Northern Virginia, we have about 50 RSUs deployed just outside the Beltway, kind of in Northern Virginia, kind of southwest of DC. This is a little bit different map of that Northern Virginia test bed. The lighter color pins that you see are on intersections where there are arterials where we have a connection into the traffic signal cabinet. The rest of them are on freeways, and we've done the deployment in this way to support the testing and the development of a variety of different applications, both on arterials for things like SPaT and MAP, enabled applications, and also on freeways for things like queue detection and merge support and things like that. Okay, so behind all that equipment that's been deployed on the road, all those DSRC radios, we also have what we call the VCC Cloud. This is a homegrown server-based application that functions as an application processing space. It's a data hub, so all the messages from the system, including BSMs coming in from all of those deployed RSUs, and from a public cellular API also come into the cloud. So they kind of all get brought into the same common spot and they get archived, or they can also be processed in real time if there are applications that require BSMs from multiple locations. To support the development and, I guess, the creation and deployment of traveler information messages, we also tap into VDOT's data sharing sites. So this is the same data sharing system that powers their 511 system. So we take all the traffic incidents, work zone definitions, active traffic management data, variable dynamic message signs. We pull all those into our cloud, turn them into the appropriate messaging standard. In this case, that's typically a traveler information message, and then we broadcast them back out either through the cellular interface or through the roadside DSRC units as well. We have a couple of other applications that we tap into. One is called the VCC Monitor. I'll show you a different picture of that here in just a little bit, but that's really a situation awareness tool that allows us to understand what's happening in the environment. That includes the uptime and the reliability of the deployed equipment, but also when we have actors that are interoperating within the system, we can kind of tell where they are. Largely that's for research support as opposed to any kind of actual operation. I mean, because of the anonymity issues, we wouldn't necessarily want to be able to track those individuals interoperating over a period of time. So just keep that in mind, that it's really about doing the development and validation efforts here more so than long-term operation. We have a connection to a public data sharing portal called smarterroads.org. That is a VDOT data sharing site, so we push SPaT and MAP messages and now traveler information messages out through that website, and they can be received pretty much by any third-party developer who wants to get them in near real time. Also connected to the cloud, we have our roadside DSRC units, and on those 30 intersections where we're connected to the signal controllers, we are pulling in to the roadside unit timing data from the controller so that we can generate the SPaT messages locally. And up in that Northern Virginia region, VDOT operates the ATS D4 firmware on the intersections that we're engaged with. They have about 1,400 that are deployed in that entire environment. We're tapping into about 30 of them. And so we had to work with ATS, or Advanced Traffic Solutions, to develop a custom interface to push that data from the controller to the RSU so that we could compute and create and format and broadcast the SPaT messages coming out of that unit. It was infeasible for us to be able to pull in a different, maybe a SPaT-enabled controller and swap it in just because of the way that they control and manage that environment. We had to work with what was there in place and then add on to it. So that has taken a bit of work to get that interface together and to make sure that we've debugged and validated all the data that's coming through from that. So we also have occasionally had fleets of vehicles, and when I say occasionally, they kind of come and go as we have other research studies operating in the area. So we pull in, when we say have like 50 to 100 vehicles, we can deploy them with onboard units in place, and they will interact with the environment. And just depending upon the goal of the, I guess, the parallel research study that's going on, we may or may not enable applications to provide, I guess, information back to the driver based on what they're receiving through the roadside units. So again, from time to time, we have a lot of vehicles up there to almost no vehicles. It just depends upon what's happening in the research space. Work zones are of a particular interest to VDOT, work zone safety in particular. And so we've been developing a variety of different applications to help provide higher quality, higher resolution, and more timely work zone data. And that's largely what I'm going to be talking about throughout the rest of the presentation. So some of our recent activity I'll just cover before I move on into the work zone side of things. We have ongoing SPaT and map validation. I mentioned before, we're really doing this to assess our readiness to deploy the applications that we'd like to run underneath or with that data. And we've gone through, I guess, one iteration already of collecting a variety of different SPaT and map data points out there in the field, and we're doing things like measuring latency and accuracy. Of course, because this is new, we have found a few incidents from time to time, and we are in the process of correcting a few of those. We have also gone through the SPaT verification document that Blaine alluded to before, and we've made some other updates in terms of our interpretation of how map files should be deployed. And so all those updates and changes are in play right now and should be deployed here by the end of the first quarter, and we'll do another round of validation. We hope to publish those results off that second round, and we will look for a good opportunity to do that. And if there is an opportunity to come back and present to this group, then we would do it. We'd be happy to do it at that time. We've also deployed the GPS RTK correction system. So within that northern region operation, there was not an RTK system or a base station that we could tap into for public use. So we went ahead and deployed our own base station in the area, and we are taking in those corrections. Now they come into, the actual base station itself is mounted on a traffic cabinet at an intersection, and we are taking that data into the cloud and being able to broadcast it. And most of the region that we're operating in up there can take those corrections without a whole lot of loss of, I guess, accuracy or correction effectiveness just based on distance, because the further away you are from that base station, the less effective their correction is. But regardless, we are currently supporting the broadcast of RTCM messages from that area. We have done some accuracy assessments, some field observations and collecting data to understand, with a corrected GPS versus a non-corrected GPS, what are the differences in accuracy. We've done a first round of data collection, and we've shared those results with VDOT, but we have not yet published anything. We hope to, again, have a second paper coming out on that at the end of the first quarter that will discuss what accuracy we're actually seeing and what the benefits are of having that RTCM broadcast in place. Then on the work zone side of things, which is kind of more what I'm here to talk about, we're essentially trying to create applications and a flow of data that is more accurate, more timely, and a little bit more precision that we normally get from infrastructure data sources such as the 511 system. And we also want to look at some of the dynamic parts of that as well. So like, can we create a smart vest for workers to wear that will localize them and give their position updates on a regular basis? And can we also create applications for safety service patrol folks so that they can understand, where they are, so we can understand where they are and what kinds of incidents they're dealing with on the side of the road. I just had a connection interruption there. It's updating. Okay, there we go. Okay, so again, the reason or the purpose that VDOT has us looking into many of these temporary road configuration changes is because they're a bit of a challenge for connected and automated vehicles. And we're trying to prepare the roadway environment for them to use in the future. And so if you look at things like work zones, traffic incidents, unusual or unplanned events, I think many of the AV developers are trying to, build their systems to be able to detect and respond to those things automatically. But we believe it will be much more effective if we can come out with a more of a detailed data solution that is standardized, that everybody can act on, or all those automated and connected vehicles can act on, that is maybe, I guess, a little more timely and a little bit more effective and consistent across the different receivers. So, we also acknowledge that some of our infrastructure owner-operator source data could be a little bit more accurate and timely and perhaps detailed. For example, on a work zone up in Northern Virginia, we typically get, from mile marker X to mile marker Y, and, perhaps they indicate what kind of activity is occurring, and maybe if there's 1 or 2 lanes closed or a shoulder closed. But we would like to have a lot more information about things like where tapers begin and end, and other hazard sorts of implications that come with those kinds of zones, I guess. And we also, essentially just want to be able to exercise these systems and be able to deploy them statewide, so that when we have corridors that I guess are developed for both connected and automated vehicles, that we're ready to pull the trigger on pushing that data. I mentioned before some of the additional connected and automated vehicle data elements that we're interested in. I apologize, looks like some of the text wrapped on a couple of these slides. Essentially, all throughout the work zone, from approach to transition to where the activities areas are, we're looking for a little bit more detail. So, typically that for us, that's going to be lat-long geographic position, a general description of what's going on, when and where lanes closed are closed, and when and where the activity areas are, so we understand the risks associated when they're occupied, when workers might be a little bit closer to the roadway, and we might want to be a little more vigilant as to when collisions or conflicts may occur. Barrier types, other types of hazards, things like steel plates, sometimes we have rumble strips, sometimes we have things like reduced visibility. All those things we would like to enunciate through the data flow to make sure that the receivers are understanding what the situation is at all times. Things like reduced speed limits, they're not always necessarily consistent across the different types of work zones, and so we'd like to be able to enunciate those as well. I know that there are systems out there that can read signs, but it's, again, more effective if we can help cross-validate that with a good data solution underlying that information. Specifically looking at some of the work zone components and products that we are developing for VDOT. I mentioned before we had that VCC cloud. That's what kind of sits in the middle of everything. We've got the VCC monitor, which shows where messages are posted in terms of their geolocation and where they're relevant. It also gives us the status of all the other equipment and all the other actors in the system. We've got this VCC mobile application, which is kind of an Android-based cell phone application that can be used by an end user driving through the environment. And if they come across the geolocation for any of these messages or areas that have been posted, it'll enunciate the message to them, so it'll read it aloud to them so that they get that information as they're driving through. And that's really, in an era when there aren't a whole lot of OBUs and deployed connected vehicle equipment available on the roads, this mobile application has kind of given us the ability to do test and demonstration activities and to validate some of our efforts so that we receive the same messages that hopefully OBUs will receive in the future through integrated systems in the vehicles. We also are working on a worker and safety service patrol application, the connected worker vest that I mentioned before, and the work zone builder tool, which allows us to get a good detailed definition of that work zone prior to even when it's set up on the side of the road. Just a little more detail about VCC Mobile. I mentioned before, it can be cellular or DSRC enabled. So if you have this phone device in a vehicle that already has an OBU and you're within range of an RSU and receiving data from it, it'll take the data through that, I guess, that pathway. If you're outside of a DSRC range, it'll use traditional 3G, 4G cellular to connect up to our cloud environment and then pull all the same messages down through that. So, depending on where you are and whether or not you have even basic cellular connectivity, you can use this application statewide to get all the messages that VDOT is putting out. The VCC monitor, I mentioned before, it kind of gives us a real-time SPaT status display. It shows us the message flows and what the volumes are on the environment at any given time. And we've actually got it instrumented to show us where some of the bottlenecks are now so that we can look at stress testing if there are messages, lots of messages flowing from one area to another. We can understand what that volume is. So this really gives us a good idea of what the performance of the system is, but also what's happening on the environment at any given time. So VDOT, in order to get us I guess, or enable a really positive flow of high quality data to this system, VDOT has contracted us to build what's called a work zone builder application. And the idea is that, rather than lumping a new task onto these folks who are designing the work zones, can we give them an application to make their job a little bit easier, to actually help them facilitate the design of the work zones, and then use that as the supporting, I guess, environment where you produced that detailed data that we'd love to see, in the work zone definitions. And so it's really designed for contractors to use to sit down and tap out or to create a work zone based on the guidelines and the MUTCD and work area protection manuals for the state, and then how do they flow that data into the system, and then how do they use it to maximum benefit. And that's where we have the design, management, and field modes. So the design mode itself, again, you use a map, you find the location of where you're planning to do your work, you tap out an activity area, and then you select a template you want to apply. So for example, if I want a TTC 4.1, if I'm going to close down a shoulder, I would apply it to a certain area. The application goes out to the work area protection manual and pulls out all the links that are desired for things like buffers, where all the sign placements have to be, whether or not an aero board or a shadow vehicle or a TMA needs to be used, the types of barriers that are recommended based on the time of day and the type of work zone it is, and then the links and positioning of the I guess the tapers, and so how many, I guess the dividing devices need to be added to the inventory. And it essentially creates that entire map and puts it into the map. I'm sorry, it creates that entire definition of the work zone and puts it onto the map. And then the end user has the ability then to adjust where those features are based on local conditions. So for example, if it puts a sign in an area where maybe there's a driveway, you need to adjust it one direction or another, you can do that in real time on this definition. And then it kind of keeps everything else in sync and updated such that your hopefully the end definition of this is a work zone that can a work zone definition that can be validated and approved by VDOT after it's submitted. And so this gives us the ability to also create an inventory so that the contractor, when they go out to set up I guess the work zone, they can understand what they need to load on the truck, and so they can use it to facilitate that part of the process as well, making that part of the job easier. Oftentimes there are individual features you need to add that aren't in the template, so we have a feature palette that allows you to pull down individual items like additional signage, maybe rumble strips, things that aren't part of the normal template that you want to add to that work zone. Then you can go out and create those as well and put them onto the design so that they can be reviewed by a VDOT work zone inspector. The management mode is then what you use to kind of set up the review, revision, and approval process. So once I build this work zone, I say validate and submit. The validation process will go through and make sure that you're at least adhering to the minimum distances for things like buffers and barrier types and things like that. It then goes to a VDOT inspector who reviews that definition online, and they either approve or don't approve it, and they give you some feedback and then send it back for revision. That's always a possibility. From that then, you update the statuses and dates as to when it will be deployed, and you can use the tablet to keep that in real time. And we're building in also a workflow for those contractors so that, if they have a work zone that is supposed to be active on a particular day, we can give them a notification when they open up the application to say, hey, are you really there? And what will be your hours of operation for the day? So the idea is here to really kind of keep that data as up to date as possible. We are then integrated with other VDOT systems, and I say loosely integrated, meaning we output data from our system that is easy to enter into the other systems. We don't do a direct integration just yet. VDOT would like us to exercise the system a little bit more and gain more confidence with it. Sometime in the future, we hope to be more tightly integrated where we're directly injecting data into things like the VA traffic and the LCAMs, which is their lane management system, sometime in the future. The field mode then is another kind of mode for the device. With its GPS, you can take it out into the field and use it to help localize where you want to set up the work zone, including where sign placement should be, where the beginning and end of the taper is, all those kinds of features. So as you drive through, it'll give you a countdown of distance to where that feature should be located, and you can use it to measure distances. You can use it to position individual types of features of the work zone itself. So it's a really hopefully easy way to, number one, go out and deploy what you've designed, but number two, if you get out in the field and see that you need to make an adjustment, it makes it easy to say, hey, I'm in this particular location, I want to move this sign to this location. You can do the update in the field and then also be able to push that into the VDOT system quite rapidly. Okay, so moving on to the more dynamic elements of the work zone, the Smart Vest system. This is a cell phone-enabled device that's got a GPS chip that is RTK corrected in it to give higher positioning accuracy. Battery powered so that you can use it throughout a full shift. Really what you're trying to do is get this onto a worker and make it easy for them to comply with being there and giving their positional information. So from this, we essentially take what is I'll call it a very low rate PSM from a human, and we put it into the system, and we can use that to compute when there's going to be conflicts between passing motorists and that worker on the side of the road, so that you can either give advisory information to the motorist or to the AV that's passing by, or potentially sometime in the future a conflict warning if we get to high enough accuracy and enough low latency so that we can do collision avoidance kinds of messaging. That vest is equipped with LED lights that can flash, a haptic belt so that we can give haptic cues if there's directionality, but also audio on each of the shoulder pads so that you can, in a very loud way, present messages to folks. We're testing all that, those types of responses so that we don't startle workers and or annoy them. So there's going to be a bit of a development activity and a test with some real workers, and then we'll tune up, kind of what those responses look like and embed them in the system, but it will be configurable moving forward. So our development on that is we hope to have a batch of those created in Q3 of 2019, and we'll do the final integration in at the end of the year here in 2019 for a full-up demo. I mentioned before the Safety Service Patrol application. Up in Northern Virginia especially, VDOT operates a fleet of Safety Service Patrol vehicles. We decided to create an application at their request that allows them to choose whether they're on duty or not, and then what kinds of activities they're responding to. And this includes things like crashes, picking up debris, fuel assistance for motorists. It essentially puts a real-time message out through either Waze or through that smarterroads.org data sharing site that says where they are, what they're involved in, and so it can be picked up by those third-party users and presented back to the drivers. It's also connected to the TOC, so the TOC gets that real-time update about where they are through an automatic phone application. We're looking at adding additional features, like if they need to close a lane temporarily and they have potentially some information about how to navigate through the particular incident, then we can add that in there as well. So we're kind of at the first stages of deployment of this application, and it will also be used for other VDOT roadside workers, whether I'm a work zone inspector or some other role. The application at the top level allows you to choose a role. In this case, it's Safety Service Patrol, but it might be just that you're a roadside observer or something like that, and you can set it up and get those same kinds of notifications. I mentioned that work zone server application. We do run a work zone data manager. This is essentially taking in all the work zone data and turning it into, I guess, reasonable outputs. Right now, that's kind of a travel information message. In the future, we expect that to have more detail, something like a roadside safety message, which has been proposed and is working through its way through some of the standards organizations that can give more detailed information about a localized map message that helps you navigate through that work zone area. We also have it also streams data to local dynamic actors. So if a vehicle is approaching that has our app on it, and we see that we're fairly close to a worker on the side of the road, we'll begin to stream that real-time position so that you get a much better opportunity to provide conflict alerts should a conflict situation arise. And then we're also, again, pushing all that data out to the public portal that could be consumed by third-party application developers should they need to pick that up and want to do a better job of telling you what's going on the side of the road. All right, so our next steps with this entire environment. So you notice we've got a few different kinds of application pieces and parts that we're developing through projects throughout the first half of the year. Those will all wrap up hopefully by the beginning of the third quarter, and then we'll be able to go out and demonstrate them. And we're anticipating doing more of a putting it all together kind of a demo at the end of the year where we demonstrate all the individual features together, maybe in 1 or 2 work zones. And we hope to have that be a bit more of a public event so that some of you, if you're interested, could come and participate and ride along and see how it all works. Beyond that demonstration, we'll be looking at an end user application and naturalistic driving study evaluation where we put cameras and other sensors on board the vehicles and then understand how the individuals are reacting to these messages. So are we adding distraction, or are the drivers reacting as we think they would given the information, or are they doing something different? And so we intend to study that for probably the 12-month period during the year 2020 and beyond. So that's what I had, I guess, to explain to you today. Are there any questions, or I guess maybe I'll toss it back to you, Adam, if you want to perhaps moderate if there are questions from the participants.
Mike, thank you so much for a fantastic presentation. Thanks to all of our presenters. Yes, for those with questions who haven't typed them in yet, please feel free to do so in that question discussion pod there on the right-hand side of your screen. Mike, since your presentation's still up, a couple questions for you. It looks like that came in. around the smart vest system and the work zone. So the first one there is would the smart vest system be used to notify the vehicles within the work zone of the precise worker position? And then somewhat related is every time someone moves a barrel or a sign, what does the map get updated? How does that process work?
Yeah, so with respect to the vest itself, I mean, we're looking at what can be done there. So if you have, a variety of workers on the side of the road in a particular activity area, we of course don't want to put out an individual message for each of them. So our work zone server application takes in all their locations and tries to generalize it down to saying, hey, there are multiple workers on the side of the road in a certain distance. So at the top level, there's kind of an advisory message, just letting you know that, hey, people are there and it's, the region that they're working in is some X number of feet ahead, 500 feet, 250 feet, whatever. And then occasionally, or what we have tried to work on are looking at developing various threat algorithms which indicate, okay, here's the type of barrier that's being used in this area, here's the active lane of traffic, here's the location of the worker, what is the probability or the likelihood that they're going to make their way into the roadway. And then based on their current movement and their likelihood of getting out in the roadway, we may or may not provide I guess a collision imminent type of a warning. That is all very much under test and evaluation. We think that there are many challenges there, but that is kind of the end goal. It would be really nice if we can get there. It all depends upon latency. It depends upon the accuracy of the algorithms that we can develop as to whether or not that's going to be a useful set of info. To answer the question about when, go ahead.
Oh, no, please go ahead.
To answer the question about the barrels and the signs, ideally, that whoever is out there managing the work zone would be able to update the location of that sign, essentially bringing it up and saying snap to my current position. Again, if it's a contractual requirement that they do that, and that's being managed by VDOT, we'll have to wait and see exactly how that goes. I'm not sure as to what kind of compliance levels we'll get. Part of it depends, I believe, on sort of how well we design the user interface and how easy we make that tablet application to use. I realize that it is likely that we'll probably have I guess a little bit of momentum or inertia to overcome to make sure that the information is often kept up to date. So we'll have to wait and see how that goes as we get into the field trials.
That's great. With the vest, I mean, using it for work zone safety seems like an incredibly important and perfect start to testing that out. Have you or your team thought about other additional uses, around either pedestrians or school children or anything else where this could be implemented?
We've talked about vulnerable road users as a start. Maybe folks that are perhaps a little bit more likely to be in the way of traffic, whether it be folks with disabilities or whatever else, maybe as a first step. I think in the long run, if we can get the cost down and make it cheap and make it easy to use, again, there might be a lot of different types of applications. But certainly, we talked about folks like the Virginia State Police, would they want to try it out when they have, if they have a trooper that's outside of the vehicle? There are, of course, a lot of issues with that about whether or not law enforcement wants to be pinpointed on a theoretical map. Yeah, I think that there are plenty of other applications and spaces that it could be moved into. If we can get a good, I guess, definition of data flowing and we can make it such that, that information is standard and expected by CAVs, then we can start to look at other applications.
Great, thank you. For Cameron, a question came in about GDOT's Green Speed app, and the question is vehicle acceleration from current speed taken into account when providing the target speed to meet green, or does the app assume the vehicle needs to instantaneously be at the target speed?
At the moment, the target speed on there would be an instantaneous speed. We've looked at a couple of different ways to do that and to how to take in different vehicles' acceleration capabilities, but for testing and to minimize variables and to kind of help support just validation of the applications, right now it's just putting up the instantaneous speed.
Thank you. And another question came in there that Cameron answered around RSU management application being under development. So be sure to take a look at that in the box. The other question I had, Cameron, during your presentation was the in-vehicle interfaces and what are the plans to adapt those for future deployment either in vehicles or where do you see those going?
So the in-vehicle apps that we have right now, as Cameron mentioned, were predominantly engineering interfaces. I mean, they were primarily designed for proving that the data coming across is valid and that it can be used, and then to demonstrate and get people thinking in the car of what kind of applications could utilize that data, rather than coming up with the clean in-dash OEM, real simple, minimal interface that really hides all of the data in the back end and potential. So, I mean, our intent of those applications is to continue to push out, okay, what other applications could utilize this? The more people that we show it to, the more people that see the different kinds of data, the subtleties behind it, and the timings and the lanes and the intricacies of what goes into the applications, you get additional perspectives and ideas and thoughts on, oh, well, maybe you could take these couple of fields of this piece of the data here and come up with a new application or a new way to present it here. We're trying not to constrain it and come up with that final end OEM interface. So it's really kind of a development, testing, support type application is how we see it.